right, 10.5 is going to be the other ways that angles and circles can meet. So here we have an inscribed angle. B is on the circle, so this is an inscribed angle, and so it's going to be equal to half of the arc. And that's exactly the same as back in section 10.4. Inscribed angle equals half the arc. The only difference is all the angles not in the circle, but the rule still stays the same. Here we have two lines intersecting and it's on the circle. Here we have two lines intersecting, it's inside the circle. Here we have two lines intersecting, the angle's outside the circle. So that's really the three choices we can have. Now we said central angle is the same as inside the circle. So if it's inside the circle, it's equal to the average of the arcs. It's equal to the average of the arcs. And this shows it right there. We have arc EHD, and we have arc CIF, and we have angle G right in here. And you can see that as I change that angle and make the arc bigger, it makes the angle bigger. And the two, 102 plus 75, 102 plus 75 divided by 2 is equal to 89. So this is angle equals inside the circle, angle inside the circle, angle equals the average of the arcs. Now here's the angle outside the circle. It's going to be equal to the big arc, BD, minus the little arc, EF, divided by 2. It's going to be BD minus EF divided by 2. So again, we see the big arc is 90 here, the little arc is 27, and this angle is 31, because 90 minus 37, or 27, is about 62, and 62 divided by 2 is about 31. If I change this a little bit, I'd like to do 100. If I can, there's 100, so I made that 100, and then this one's 30, so 100 minus 30 is 70, 70 divided by 2 is 35. Big arc minus little arc divided by 2. So vertex in the circle, angle is equal, central angle equals the arc. Vertex on the circle, or inside the circle, you're going to equal half the sum. On the circle, half the arc. Outside the circle, half the difference. All right, those are all of the different ways.